This is Scott from KIG. It's August 2022. We're going to do a runoff video today of this 4-ton, 460 volt Chill King vertical air-cooled chiller. This is a 460 volt unit, like I said, model GV048CK4, serial number CK1813196, meaning it's a 2018 unit. It being 460 volt, this draws about, let's see, the pump draws 1.8 amps, and the minimum circuit ampacity 11, maximum fuse 16. This is an R410A refrigerant machine. The chiller is outdoor rated. Some people do put these indoors. I think its new home is going to be indoors. Very simple, very reliable design. We've provided many of them. This case here, it has a 44-gallon insulated reservoir tank, and it has a 460 volt 3-phase pump. The pump draws from the tank and goes out to the process. You'll see a shut-off valve right there. That's to be left open at all times unless you're servicing the unit, but when it's running, you don't want to limit the pump suction at all. The Chill King chillers have a internal fixed bypass line. That's this third line you see going from the pump, and it goes up and back to the tank. So it's always bypassing a little bit of flow, so you don't need to, with the exception of very rare cases, you don't need to put on an additional flow bypass, which would be commonplace with other chillers. It has a high pressure, adjustable high pressure switch, adjustable low pressure switch. It also has fan cycling, but based on pressure. So this chiller, when the compressor is running, the fan does not necessarily always have to be running. It depends on ambient air conditions. And the unit does come with a refrigerant sight glass there also. We just set up a test loop when we run these in our shop, and that is the outlet. That's 1-inch NPT, and we just have it looped back. We have a valve to throttle it down a bit, and that just loops back to the return here, which is 1¼ inch female NPT. We got to throttle down the flow a little bit because without any restriction, the pump would spin a little bit too fast and possibly over amp. So the tank has a lid. It is bolted on. The bolts are kind of on the perimeter, but for testing, we have it unbolted. And it also has a vent. You may want to just fill it through the lid, or you can just fill it through this vent, which the prior user put this little copper tube on here. But just keep in mind, it's not a sealed, pressurized loop. So if you overfill the tank, it's going to start leaking out through that lid. Just be careful of that. Depending what your application is, you may want to put a check valve on the output and a normally closed solenoid valve on the input if you have overhead piping and substantial volume up above, such that when you power the system down or your process down, that would prevent any overflow back to the tank. It is important that the tank be kept very full, pretty much to the top. That's the nature of the design, because the evaporator for this chiller is a coil submerged in this insulated stainless tank, and it has to be covered with water or glycol at all times. Here you have a little drain plug. We have all the stainless side covers off the unit right now, just for the runoff. When you do first bring power to it, and you or your electrician will bring power up to the bottom of this little electrical enclosure, and again we have the cover off of it, and that's where the controller is. You're going to bring power into here, and to the left contactor it says power in, and you'll see we have 3 hots, black, white, red, and a ground. But you do have to check for phase rotation. The simplest thing is to get somebody to come down with a flashlight, look at the side vents of the pump, and just toggle the power quickly and make sure it's rotating clockwise. If it is not rotating clockwise, then you change the incoming power. Don't worry about the contactor that says pump, because that's already synchronized with the compressor. If it's not rotating clockwise, you're just going to swap any of 2 of these 3 leads. Or have your electrician do that is the correct thing to do. So controller is very simple. I'm going to first turn the system on. Just a toggle switch. That's the pump. It sounds a little loud going through our little valve loop out in the back of the chiller because we're restricting flow. But we just simply go to the Soranco controller here, and it's pretty warm today here in Massachusetts. I think the tank's already just up to 80 or so, and we're going to press set. Shows what the temperature is, 81. Set again, Fahrenheit, leave it there. Set again, that's our set point. We're going to bring it down to, say, 52. We'll call it 50. Press set again. We currently have the differential at 3. Don't run it any tighter than that. It'd actually be nicer if you could run it a little bit bigger, depending on your process. Press set again. C1, that's what we want to leave it in for cooling mode. Press set again, and the compressor and fan just turned on, and we're chilling. Again, this is an outdoor rated unit, but you can put it indoors if you want. If you're going to run a fluid temperature below, say 48 degrees, you do want to see glycol in there. The glycol percentage will depend on how low a fluid temperature you run it, or depends on the outdoor climate if you put it outdoors. Even if you're running it fairly warm, it is always helpful if you run a little bit of glycol, but there are a fair share of these out there running just straight water. So it's going to take a while for that volume to start cooling. So we're going to come back to video number 2 as we approach that 50-degree set point.